Hello and welcome to another video by the Hoyle Computer Club. So today we're back on Parrot OS HTTP edition. Today we're going to be trying to install a Radare 2. Radare 2 is a reverse engineering framework, fairly straightforward to install, but I tend to use it in my workflow, so I thought why not make a video of going collecting it and installing it. So first thing I'm going to do is open up a web browser and I'm going to search for the Git for Radare 2, so Radare 2 Git, and we should get like a GitHub, there we go, the first thing there, Radare org/Radare 2, and it's a really good sort of debugger and reverse engineering tool set. It can visualize a lot of your code and your actual opcodes that are in there, and it can reverse a lot of different platforms. It's not just like x86, it can do a lot of different ARM platforms and all sorts of things. So it's a great toolkit to use when doing any sort of binary exploitation or anything, and it's also free and open source. So first thing I'm going to do is take a look at this. If we look at the description, it says R2 can be installed from Git or via pip or using R2env. At this point we're going to do the Git version, so we can like literally do a Git clone of it, the installation, and then what we can do, we can actually go off and install it. So it's quite straightforward to actually do. Let's go and take a look at this. Let's see if I can make this a bit bigger. So if we just clone the whole of Radare 2, this part here, so it's these two commands here should do it. There are certain caveats, certain systems may not have certain things in, so we will play it by ear, as I haven't used Parrot OS enough to know whether it's got all the prerequisites and stuff, but we should be good. It should grab all the prerequisites using the shell script, but we'll see how it goes. So I'm going to use this git clone Radare 2. Now I don't necessarily want to do it directly in my home directory really, so what I will do is I'll still do it there, but I'm going to do it hidden. So we've got Radare 2, so instead of just doing what they've said there, I'm going to do it to .Radare 2. So now it's going to be a hidden folder instead of us seeing it and making it look a bit of a mess. So that's getting cloned into there. You could also clone into /opt if you want to do in optional files and stuff like that. There's a few different ways of doing this. So once we've cloned it, it should be as simple as installing it, but we'll play it by ear and make sure it's doing what it does. This should be a fairly shortish video. I'm not going to go over too much with this. This is just another way of installing software. So instead of just compile everything using a download, untar something, and then do the configure, make, install, this is another way of installing software. And you'll find there's a few different ways, and you'll get used to them along the way as you kind of utilize Linux in general. Like with Windows or any other operating system, there's usually a different way of installing things. So I'm going to pause for a moment though, because it's taking a little while to get down, and then I'll see you in a second. Okay, that's finished cloning down. Now we're going to literally change directory to, well actually we don't even need to change directory, we can just run this here, like Radare 2. But again, I need to slightly amend this. If I paste this in, that's great, but it's not directly in Radare 2, it's in .Radare 2, sys install. So now what it's doing, it's going and making sure it's up to date. Cannot find Capstone, so what it's going to do now, it's going to see if it can find GMake. It's found GMake. It's configuring the build system. Now it's checking out Capstone, so it's pulling Capstone from the Git repos. It's checking out all the different bits and pieces, look, vector, ARM and everything else, and then it's going off and building those things. So it's going and doing an actual build. So it's kind of like doing our configure and make install, but it's all scripted and doing its thing. So we don't have to worry too much about all this, because there's a lot of, it compiles all the prerequisites and all the libraries and everything to do with it as well. So what we're going to do is we're going to leave this going, because this may take a little while, and then we'll kind of get back to it and make sure it's installed. Okay, during the automated installation, it's asking me for my sudo password because it needs to get root privilege. So I'm going to give it my super secret password, and it's going to continue on. And there we go. Let's take a look now and see if we can get R2 -- version. That's fine, missing file to open. Let's just do R2 with nothing there. There we go. Okay, so literally it's saying R2, we've got a lot of different things we can do. We can patch things, we can open projects, we can look at what architecture that we want to use, whether it's big endian or little endian and stuff like that, and look at different addresses. Or we can just open up R2 and the file and start debugging it and analysing it. We're not going to do any analysation, or we're not going to really dive too deep into it, but let's just run R2 with /bin/ cat, for instance. So now we can analyze it, so we can do AAA. It's now analyzing all the flags, it's analyzing all the imports, it's looking at the functions and arguments and locals. Then we could sort of like, you can run it. You can do a lot of different things with this. So we can kind of take a look at different things. So let's say that we want to do, once we've analysed it, let's say that we want to take a look at what we can do. So we can print instructions, we can print a load of different things. It's P. Well, literally, P is just a print command in general, but we can sort of just literally give it a bunch of things to do. But like I said, you can feel free to have a read through the documentation and the usage. So here I list all functions, AFL. So let's go and do that. Just quickly, just over this AFL. So this is all the functions. Notice they don't really have very clear names, function.00 blah blah blah. And that's because it's just telling us like the memory address of it, because it doesn't really know what they're called unless there are certain debug symbols inside the binary. Now in this case it's bin bash, so it's kind of stripped, so there's no debug symbols, so it has to make up names for it. So it's just saying function.memory address. So if we turn around and say okay, let's print a hex dump, so we can do that px and give it sort of how much we want to print. So px64, it's printed a hex dump at the current memory address of what's there, so we can kind of look at the memory of that program. Obviously it's not very useful always directly in that sort of thing. We can look for the main, so we can seek to the symbol main if there is a symbol main available to us. So we can say seek symbol.main, cannot seek to unknown address. Now the reason for that is, again, because there are no debug symbols in this. Yeah, so we'd have to kind of figure out where main is. Do you know what I mean? So that's something that you would not be able to do if you don't have actual symbols. But if you have something that says it's not stripped, that means that it has the debug symbols available for you. So that's where it becomes a lot easier to look through the file. But let's seek to maybe this. Let's copy this and see if we can do to now if we actually take a look and go, okay, well, what can we do? Let's do a PDF. And this will give us our symbols and all of our bits and pieces and what we've got. So basically it's doing a disassembly with a like a graph showing you the way how things are going. So if you have a look, we've got push R12, move R12 RSI to R12, push RVP, pushing the base pointer, setting that. This is kind of like the prelude to a function call. So this is setting up all the arguments. So it's set up arg2, arg1, how big the arguments are. Now it's subtracting 8 from the stack pointer to make some room on the stack. Then it's allocating some memory. Yeah. So it's calling malloc on size t. So literally there's a call to actual malloc, which is basic memory allocation. And then it's running. It's copying the AX register over to the destination index. Then it's testing RAX versus IRX, and if they're not equal, jump to this address. So this is where the arrow comes in. It shows you where the jump would happen. Yeah. And then otherwise we'll test R12 versus R12, and if they're not equal, jump to this address. And notice that jump goes outside of the thing and calls another function. Let's have a look. So if it didn't jump to either of these, then it would fall down and hit the add RSP8, so it'd move the stack pointer, and then literally this is the closing of the program as such, almost. So then it would do a mem copy of some stuff. So allocation, copying. So it's jumping to the mem copy. That's setting up the next prelude of another function call, and then jumping to mem copy to do that. So in other words, this is doing the stuff of what memory to copy and how big it is, and then setting up mem call. But if this test was not equal, it would have called this function. So here we have another memory address. So you know that it's function dot memory address. So we could actually sort of copy that and say seek to 0x and paste the memory address. Now if we do our same thing that we did earlier with this PDF, we can take a look at the function. So now it's looking at some references, no return, interesting, so it doesn't have a return call. It's now setting up the function. So it's showing you a lot more information than just reading some bytes, you know what I mean? So here's some bytes, but here's the disassembly. So if you look at the difference here, but no, so we've got 4883, we've got 4883. So it's reading the same things. 48 is subtract. Then we've got 83 EC08. Now the 08 is here. So we've got like all of the different possible bits and pieces here, but it's the same, look. 830. That part there is that part there. So that bunch of hex code or numbers is the same as this if we disassemble it. So that's the assembled version of this. Again, I didn't really want to go super deep into this, so we're just kind of talking about it quickly. I've kind of gone off on one. But suffice to say, it's installed and working. Let's quit it. So it now is installed, which is great, and that was our main purpose. But I went off on a little bit of a rabbit hole tangent, but that's awesome. Okay, so hopefully you enjoyed this. I will leave links to the repository in the description. Remember, if you enjoyed the video, please add a thumbs up to it because it does help with the algorithm. And if you want to get any sort of notifications, feel free to subscribe, and remember to button bash that bell icon, I believe it is these days. Have a good one. I'll see you in the next one. Bye bye.